Hey, how's everyone doing? Good Monday morning. We got some coffee ready to go. We got the doctor mug. I am installing Microsoft Word again as we speak. I meant to do it and then I was like, wait a minute, I'm going to do this so when I draw in Microsoft Word or I draw in Office, we know what happens. No problem. Thank you, Leslie. Good to see everyone here. I saw some questions to start. People were asking about the Canvas content quiz. We had the Kahoot last night. So check out the Kahoot last night. Lots of good advice. Can you go over section 2B on the project? I'm still confused on the write-up. What does section 2B say? I'm going to need your help here for a moment, Sarah. I'm literally installing Microsoft Word as we speak. Here, I'll show you in the background. You ready? Let me, Mubot is awake. Mubot, are you awake, Mubot? Let's see if we can add some points right here. Since I'm reinstalling Microsoft Word, I can't actually see Microsoft Word related things. Let me see right here. Yeah, we'll go Mubot. Mubot, you awake? He might be awake. We'll see if he's awake. Let's reset Mubot. Mubot reset, and Mubot is resetting. That might have just done something. And so I see Sarah wants to go over, take a screenshot of the output and interpret your graphic. Make sure your description of the shape and the center are appropriate. So we're doing a histogram right there, doing some sort of quantitative. And let's go ahead and take a look at that. Mubot is waking back up here. Good to see you again, Kinga. Good to see you. Good to see everybody. And Mubot is awake now. So let's add those points back on. And let's take a look at interpreting the shape and center. And so make sure to describe the shape and appropriate center and spread of a distribution. Okay, let's do that. So let's hop in here to a data set. This is a totally different data set. Also, it's a random sample of the amount of days. That is correct. You are correct, Sarah. It is going to be random days that we are doing. So let's go over here to the main screen. Okay, Microsoft Word is still installing. So we're going to just let Microsoft Word do its install thing in the background right here. This is question 2B, I think it is. 2B on the project. So when we're doing this project right here, we'll do a distribution of a quantitative variable. So this is going to make a histogram right here. So this is what you're doing on the project, but just with a different variable. Who's following me with this right here? Like, this is a quantitative variable. This is a quantitative variable. And how do we know it's quantitative? Well, we're just going to pick something like this right here. Make sure to follow the project instructions. Hence, I'm not doing the exact project right now, but we have a quantitative variable. So we see right here anticipated starting salary. And so this is a quantitative variable because it's blue. And we're going to click OK. This is going to give us the histogram. We're going to go here to the first red arrow, and we're going to go to stack. You know what I'm going to do? I'm going to zoom in on this. Watch this. Want to see some magic? Let's zoom in right here. Here we go. So the first red arrow, we go right here, and we go to stack. Stack is going to allow us to put in horizontal layout. Once you go to stack right here, we're going to go to the second red arrow. We're going to go to histogram options, and we're going to go to count access. So that's the second red arrow right there that goes to histogram options, count access. And this one, what does everyone think about this right here? How would you describe the shape of this? So we gotta. Look at this graph. How would you describe the shape of this? How would you describe the shape of this? Any ideas? Microsoft Word's going along right there. Who has ideas for the shape of this? Any ideas? Kind of skewed to the right. Yep. It's kind of skewed. That's the mean right there. So that's the mean. That diamond is the mean. That's the median. The mean is going a little bit higher than the median. Usually, and I'm not saying this is the best way, hint for your assignment, usually when you see drastic differences from the mean and the median, which there's some differences here, I'm still going to go with the median because there are some outliers right here. We see a few extreme outliers, or we see some extreme outliers, and we see some mild outliers right here. Like a person who says, I'm going to make 200,000. Looks like there's two individuals right here of individuals saying they're going to make $200,000 when they graduate UT. Good. I'd like to make $200,000. You bet it, Kingo. We can do that one here in a little bit. You got it. So you'll say they're going to make $200,000. Amazing. And then we have people up here, which are more mild outliers. They're still outliers though, but 115,000, still an outlier. Is it okay if we don't include the dots on our side-by-side outflux? It should kind of include the dots. Finish the setup. Hopefully that finished everything. So if there are no outliers, we should use, generally speaking, as long as there's not strong skew. This one here looks mostly, it's unimodal. And watch out though, I do want to point this out, that if you change the widths of the bins, like this could look multimodal, hints for your assignment. This could look like it's multimodal, but it's probably just due to the bins. I'm up here in this tool menu bar, which is at the top of the Windows. If you're in Windows, it'll be up here. If you're on a Mac, it'll be at the top of your screen. If you're in Windows, it'll be up here. If you change the bar widths, it'll change the shape of it to where it could look multimodal, but I don't know. This is probably unimodal right here. Widths of bins will change the way it looks. I would say to me, and this is mine, which is different than yours, this is mildly right skewed with some extreme outliers. Because of this, I would use what and what. What is going to be the proper measure for mine? We're going to give some hints for your assignment. What is going to be the proper measure for mine? For mine, the proper measure will be what? Office is installed now. For mine, the proper measure of center will be what? For mine, the proper measure of center will be what? And I can show side-by-side box plots here next, Leslie, if you want. We can talk about that for a moment. And I can probably pull up the project now because I reinstalled Word. For mine, the proper measure of center will be what? Because I'm saying it's slightly skewed to the right. We've got extreme outliers here. So since it's slightly skewed to the right with extreme outliers, I'm probably going to use what as my measure of center. So what would be my proper measure of center? Since it's slightly skewed, median. Great job, Haley. The median. And since the median, and look where the median's at. The median's right here. So, and this is for mine. Then what's going to be the proper measure of spread? So if I'm going to use the median, look right next to it, what would I use for the measure of spread? And so do remember this is mine. This is not yours. Great job, Kayla and everybody, and Leslie. I'm going to use median for center, and right around it, I'm going to use what for spread? Not 25th, 75th percentile, but the 25th, the IQR, exactly. Your other option is to use the mean and standard deviation. Look, they're right next to each other, and this is for more normal data. Hint, 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 hint. If your data is more normal, you'll use mean and standard deviation. And a lot of times what you'll see is if it's more normal, you'll usually see the mean and the median next to each other, like on top of each other when you have more symmetric normal data. When there's skew and outliers, we use the median and IQR. Wrong buttons. Is everyone feeling pretty good about this one? Let me go grab that other question right here. We're going to have to space right here for a cut in the video. So hopefully that makes more sense on that one. We're good on this. Let's get the other question going. Let me go grab the project. Let me see this fresh install of Microsoft Word. Oh my gosh, what have we done? We got new Microsoft Word. So hopefully Microsoft Word doesn't do the crazy things with the pens anymore, or it keeps changing my pen colors. We will find out. We're going to find out if Microsoft Word has been updated. People have already turned in Project 2. That's amazing. Hopefully it's good. I haven't looked at it yet. So Project 2. Okay. Let me download the Project 2 dataset. And there it is. Okay. So Microsoft Word, will it open? New Microsoft Word. Oh, it still has all my old documents. Maybe it's not new. Microsoft Word activation with this copy is not activated. Maybe that's why everything's active. Oh no. Okay, good. No. Oh, I cannot draw. This is really bad. Cannot edit it because it's not activated. Oh my gosh, what have I done to myself? Oh my gosh. Well, let me try reinstalling this later after the stream. Okay, so let's see what questions there are. How is this not activated? UT, what have I done to myself? So I think the other question was dealing with the side-by-side box plots. Really? 2 seconds here, everybody. What questions are there at current time? And why would it say it's not activated? That's so weird. Yeah, the Chapter 14 quiz, you got it. Let's do that. While Microsoft Word will not let me. Activation failed. Okay, cool. Apparently I don't have access to Microsoft Word. Never try to reinstall things. We'll have to fix that later. Let's go over here and do Chapter 14 quiz. And let's take a look at that. We went from some Microsoft Word to no Microsoft Word. Ooh, that's going to be interesting if I'm... Let's go take a look at Chapter 14 quiz. And let's talk about how to solve this. Which one were you working on right there? Hoping to lure more shoppers downtown, a city builds a new parking garage in a central business district. The city plans to pay for the structure through parking fees. Awesome. Let's load this up right here. Chapter 14 quiz. And I think that one is, yep, it's due tomorrow. I might have to try to reinstall it in the background again. I have no idea why. Whoa, there are a lot of questions in this one. I'm going to do one thing in the background right here. Microsoft Teams, 2 seconds, everybody. I feel like it went through a different install process. Install Office, here we go. Okay, good. I think I got an older version of Office from UT, and because of that, it like installed the wrong version and must not have given me the right to use it, which is so weird. Okay, we'll let it get things ready in the background. We'll hope it works, and we'll cross our fingers. And so let's do this right here. Do you have OneNote you can draw on it? Yeah, I wonder if OneNote will work. I'm reinstalling Office again right now, so you can see that right here. It's since, Microsoft Word's been so weird this whole semester where it's changing the pen colors, which drives me absolutely crazy. I'm like reinstalling it again. So let's hope this goes through. Yeah, the 1,000 chip trial, you got it. Well, here we go. Hoping to lure. So we'll see which one we get first. We'll either get here we go, hoping to lure more shoppers downtown. And thank you, Kayla, and everyone for all the advice here, because hopefully Microsoft Word starts doing what it should do. So hoping to lure shoppers downtown, the city plans to pay for the structure through parking fees from a random sample of 42. So what is this right here? What is 42? So let's identify the notation. This is key right here to every problem we do. We need to identify the notation. So what is 42? Who knows what 42 is? Identify the notation. This is key because we'll have the formulas here in a moment. Identify the notation. What is 42? And then we need to know daily fees collected averaged 134. It is sample size, yep. And then what is 134? I'm stalling while this installs. What is 134? What is 134? Leslie, you're correct. N is 42. And then what is 134? 134 is the daily fees collected from those 42 days with a standard deviation of 14. Oh, we almost got installed here. Correct, Bailey. It is the mean and will be Y bar. We went through, at least we went through at the start some. We did a little bit, and feel free to ask some questions. Yeah, put a question in the chat, and we will do that here in a moment. So that's the sample mean. Specifically, it is Y bar, and make sure it's the sample mean from the sample size of 42. And then 14 is going to be S. Okay, it says we're ready to go. It says we got everything good to go here. Let's see. Will Microsoft Word work normally now? Will it give us our license privileges? Oh my gosh, we got a Microsoft Word license. We're good. We're good. And it looks like it didn't change anything. Well, let's go grab that question. See, we stalled and now we got it. Okay. So now we're ready to go right here. Let's take the question. We're back to normal, but does Microsoft Word work any better? Probably not. The SI, Alyssa is absolutely amazing. She is top tier. We are so lucky to have her. And we always want to know that whenever we do these problems, it really comes down to notation. So you want to be able to go through and immediately mark your notation. Please ask any questions. If you're wondering what N is, it's sample size. Wondering what Y bar is, it's the sample mean. And what S is the sample standard deviation. Oh, so yeah, Campbell, I remember you. Campbell, of course. Good to see you here, Campbell. If you have questions or just here to say, hey, that's awesome. I appreciate it. Yeah, of course I remember you, Campbell. Of course, you were just in my class. What assumptions do we have? The data values are random, so we want random right here. Do we want them to be dependent or independent? Do we want them to be dependent or independent? We want them to be independent, so we don't want dependent. It should be less than 10%, and we want it to be unimodal symmetric. So what are the three conditions? Does anyone remember the three conditions? Random, 10%, in nearly normal large enough n. This is nearly normal large enough n right here. They're just stating it differently. They're not just naming the condition. So that should be correct right there. You do not want them dependent. The idea of random means they're independent. So this part right here, create a 90% confidence interval. This is where people usually get stuck. Where do we need to go? And it won't be David M. Lane. Where do we need to go get a t-statistic? We need to go to a t-applet. So we need to go to a t-applet, and there's something we have not marked in this question. I'm going to need your help. So what have we not marked notation-wise in this question right now that we're missing? Great, Sarah. You just got everyone 50 points, Sarah. And I bet you know, Sarah, what else we don't have in this question yet that we need to mark that we're missing right now. Let me go pin this over here. It's going to confuse me. It's usually pin to taskbar. The degrees of freedom, exactly. Great job, Bailey, right there. Great job, Sarah. You are correct. So the degrees of freedom for a one sample t are n minus 1. Degrees of freedom equals 41. So we know the degrees of freedom. And we go right back here to the t-applet, and we type in 41 degrees of freedom. And I like to view my confidence intervals this way, where we do the between, where 90% is between. I'm trying to see if this is blocking. If I'm blocking it, I am blocking it. Here's the t-statistic of 1.683. So the t-statistic right here is 1.683. So we needed to get that t-statistic over here, and now we can basically solve this. So the t with 41 degrees of freedom for a 90% is 1.683. So this will be y bar plus or minus the t-statistic with n minus 1 degrees of freedom and s over square root of n. So now we're just going to plug in the numbers right here. So let's go ahead and plug in the numbers. So we have here 134 plus or minus 1.683. That's where usually people get stuck. And 14 divided by the square root of 42. Let's go ahead and solve this. We can zoom in right here. And let's go 42 square root, copy, 14 divide by, times by 1.683. There we go. And that's the margin of error. So now that we have the margin of error, we can go 134 plus or minus. Oh my gosh, the pens actually work. 3.6. Maybe I want to change colors, they'll have problems. And I don't think we need that many decimals. Let's find out. So let's go back to here. 90% confidence. And we want to go copy this. 134 plus. So that's 137.64. And 130.36. Explain in context what this means. I am 90% confident that the mean daily income, I wish it said true, will fall. Ooh, I don't like fall. That the daily income for all weekdays, no. It needs to be the mean. I don't like the word falls, which they're using for all of them. There is 90% confidence the interval contains the mean daily income. Yeah, this one's weird. This one I don't love as much. I like using my format every time, but the word falls I don't like about this, and I think that's what they're trying to point out right here is we don't like to use the word falls in statistics. This one, one of my least favorite parts of this question, just because it's much easier. We can just say, I am 90% confident that the true mean daily income for this parking garage is contained in the interval blank to blank. It's much harder when they give you something to try to trick you, and then you have to look at the parts they're tricking you on. I am 90% confident that the interval contains the true mean daily income in there's the interval. So I think that's going to be it. That one, oof. Explain what 90% confidence means. 90% of 90% intervals will contain the truth. So 90% of all sample sizes of 42 will produce confidence intervals that contain the truth. So this is a theory question right here. 90% of 90% confidence intervals are expected to contain the truth. And that's what we would get from sample sizes of 42. And that is correct right there, theoretically. So here we are with the last one. Since the 90% confidence interval, let's see, the consultant who advertised for the parking garage said it would be 141. Ooh, 141. That's outside our interval. So they said it would be 141. Since our interval does not contain the predicted average, the consultant's prediction is not plausible. We should have it. Uh-oh. Was it this one? No, we got that one right. Where did we make an error? Is it on one of our numbers? Did we round incorrectly? Everything down here should be correct. It has to be on one of the data are from a random sample. Plausible. Is it one of these? Let's find out. No, that's right. Let's find out what Brian got wrong. Ah! We zoomed out there. Nope. We got the interval correct. The distribution is it this? No? Wait a minute. Oh, it is this one. Oh my gosh. I see it. Do you see it? Someone pointed out. I mean, I see it, and then I said it correctly, and then I misread it. I know the conditions, I promise you. Read it too quickly. Read it way too quickly. Someone's watching this and gets it wrong. Like I got it wrong. What is the condition? We say that condition all the time. Sarah sees it. Less than 10%. It's right here. This is not what we want. We don't want that. We want it to be less than 10%. So it says it's putting it reversed. It's reversing what it should be. It says the sample size is at least 10%. We don't want it to be more than 10%. This is a reverse of the condition. It's the less than 10%. If anyone's thinking I don't know this condition, I promise you can watch 1,000 videos of me saying less than 10%, less than 10%. And we've written this out. I think my students will confirm. Brian knows this condition, but man, they got me good because we don't want it to be at least 10%. We want it less than 10%. That's why it's the less than 10% condition. So that definitely caught me off guard right here. I saw 10%. And I was like, yeah, less than 10%. And I didn't read it. Watch out. Nutrition laboratory one. Let's have our revenge on my Pearson trying to trick us right there. We want less than 10%, not at least 10%, less than 10%. And did someone want the 1,000 chip trial also? 1,000 chip trial? Oh man, why'd they do that to us? Nutrition laboratory. Here we go. And I think 1,000 chip trial might be next. A nutrition laboratory. Let me do a cut. Yeah. So I remember here. Cut in the video. Nutrition laboratory question. Let's do this. Here we go. A nutrition laboratory tests 60 reduced sodium content hot dogs, finding that the mean sodium content. Oh, you guys are crazy. Awesome in the chat. Let's go right here and run this question. Maybe we got more math in this question. You guys know I love the math. The math is the fun part. Okay. Does anyone notice any bit of the notation right here? Any of the notation? Yeah, of course. Let's do that one next, Bailey. You got it. Any of the notation right here, help out with the notation, and I'll go grab the important parts right here. We'll have in a moment. We have an additional thing from this. So this is going to give us one thing, but then we're going to get an additional thing from it. Here, I'll give you a hint. So this is a one sample T. Oh, darn it. So I think, yeah, that's that. Sorry, I started to. So see here, if you can get any of the notation, the more you practice getting the notation, the better you get. And I was doing some test review earlier today, and it really boils. It's so interesting what makes for good questions, but practicing the notation, I really believe in, will help you with these questions. Because then you just go to the formula and be like, well, here's what I have to put into the formula. Because I have these things. I need to use this formula. What notation do we have? Let me go grab the applet while people are putting notation in the chat. We need this applet again, so let me put it in the chat right here. There's the applet we'll go to. So there's the applet we'll go to get a number here in a moment. What do we have? The degrees of freedom for this are n-1, which should give you a hint of what that is. Any notation? Any notation? I've filled out half the notation almost already. What do we have? Close. And so close, Sarah. Good. And so it's not quite sigma. This will be S right here. And why is it S? So thank you, Sarah. And this is why I like to ask the questions, because sometimes, like, Sarah, thank you so much. I'm giving everyone 50 points because sometimes it's like we think we know it, but you're basically right. Like, it's not going to make too much of a difference, but it will make a difference in the formula. Sample standard, yep. That you get it, yep. And so that's why, and don't worry, I just made mistakes earlier, so there's no problem in getting something wrong because I just got something wrong a second ago. So it's sample standard deviation. So it's not true standard deviation, which is sigma. So the difference between these are very subtle, but I wonder if it will change to black again. But the population, oh, it's still doing the thing. Look at that. It uses the previous color for some reason. So maybe if I double select it, like if I select it again, like you got to double select it. Oh, it might do it now. Maybe that's how you do the trick. But it's some sort of bug with Microsoft Word, and reinstalling Microsoft Word did not help. But mu and sigma are population mean and population standard deviation. So just checking our knowledge right there. And we want to go y bar plus or minus t with n minus 1 degrees of freedom. Put a star on the t, and s over square root of n. And we're just going to plug in the numbers right here. So we need a 95% confidence interval. Well, that's going to be about 2. It's going to be super close. 59 degrees of freedom. And 95% confidence. 2.001. You can see it right here, and you can see it behind me. So make sure to do the between. Making a confidence interval. That's going to be the t statistic. And, oh, MuBot. You distracted me, MuBot. 37 over square root of 60 plus or minus. There we go. Okay. And so square root of 60. 37 divided by times 2.001. That's the margin of error. And so 324 plus or minus 9.56. And I just keep this stored. A quick question about the t-tables applet. When finding the critical value of t of any percent confidence interval, which option button do you use? I use the between. So when I'm doing confidence intervals, I use this right here. This is for a less than test. Here, I'll show you right here. Less than test, greater than test, does not equals test. And because usually when you do a does not equals test, you'll enter in the t statistic here, like something like this. This will be a does not equals test, a greater than test, a less than test, and then this one here I use for confidence intervals when I'm making like a 90% confidence interval like that. So does not, or let me do this really quickly on this to show it. I might change my copy paste. When using the t-applet, this is for does not equals, greater than test, less than test, and confidence intervals. So hopefully that helps. Yeah. So that's just kind of your shorthand right there. The right tailed, the left tailed, the two tails, and then confidence intervals I used for that right there. You can use it interchangeably. For the project, when it references total demand, is it talking about monetary value? It's talking about how many bikes were needed. So it's bikes, and total demand would be how many bikes were needed. So the total demand is the demand for bikes via the bike sharing kiosks in the DC area. So it's the total demand for bikes. Good question. 333.56. Thank you, everybody. Off-stars fly by when there's so many questions, which I love. What assumptions? Uh-oh. This one right here, these assumptions are a bit weird. We don't really know the answers to a lot of these. You're welcome, Nikki, anytime. We assume that the hot dogs weights are random. Yeah, we don't. They are independent. I've gotten this one right many times. Are random. Do we want them to be normal? So that one's the only one. I've gotten it right. Like, I've already done this one like 2 times this semester, and I've gotten hundreds. Is today not going to be my day? Let's find out. You're welcome, King, at any time. Is the randomization condition satisfied? We don't know, but it's reasonable to assume. I hate these ones right here. Is this less than 10% of all hot dogs? Yes. This is less than 10%. Yes. 6 axis. No. We want less than. So is the 10%? They're literally going back over. The 10% condition is less than 10%. We just missed that one on the last one. Is the nearly normal condition satisfied? We don't know, but let's assume for the moment. I hate that, but let's do it. Explain clearly what this means. I am 95% confident that the true mean sodium content of these reduced fat content hot dogs are contained in the interval blank to blank. Only worried about that one, and nope, not worried anymore. Got 100 here. Awesome. And I think we have the yogurt question next. Yogurt. So can we do this one? A company tested 11 random brands of yogurt? Of course, let's do that. So let's do the yogurt question. Hoping to lure a medical researcher using T-table. I love the T-table one. Company tested chocolate chip. Oh. Okay, cool. This one, I really am going to like this one here in a moment because this one is going to use jump. So this is going to make our lives really easy. So with this, let's go ahead and copy to clipboard and copy the data. So let me just show that again. We're going to go to copy to clipboard right here. Oh, wait, cut in the video. Help out future Brian. Take a sip of coffee. Everyone get ready for the next question. I'm trying to train myself on this because this helps me so much in the future. I can it cuts down half the time it takes for me to find where these cuts are because I'll be trying to find where the next question is. And all I have to do is go through and see where this screen is. So you're welcome, future Brian. Okay, let's talk about this question right here. This one is going to be done in jump, and jump makes our lives way easier. So we're going to get some practice reading some jump output and knowing how to use statistical software. We're going to take this data right here, copy to clipboard. When we copy this to clipboard, we just have it here in tab delimited. We're going to hit Control or Command C. There we go, Control or Command C. That's probably why I broke that button right there. And let's go here to jump. And inside of jump, we're going to go to File, New Data Table. You can hit Control or Command N. It'll go straight to one. But we're going to go to File, New Data Table right there. And then we're going to open it up. And then make sure you do this. You're going to paste normally. Now, sometimes you'll paste with column names, but we're just going to normally paste right here. We're just going to paste. Reason being is there's no column name. Be very careful. If you pasted with column names, you'll see this, and this is an error. So sometimes there is a column name, but right now there is not. If you paste with column names, the first value, which might be a column name, will go to the column name. This is the correct way, normal paste. This is the incorrect way for this problem, pasting with column names. So don't paste with column names for this problem. In the future, we might need to because there might be a column name. Hence, we'd paste with the column name. So we're already going to go ahead and analyze this data. We can figure out what we need to do from this. But let's go here to analyze distribution. This is univariate quantitative data. Hey, Caitlin, good to see you here. And let's go here and just double click. And now we have this in the Y columns under Analyze Distribution, and we get the histogram. We're going to go here to Stack. That's the top right arrow. Let's zoom in on this a little bit so everyone can see what's going on. So here we are, zooming in on this. We can go to the top right arrow and go to Stack. And now it doesn't look quite like, or does it look like those? Let's find out. Let's see how those looked. How did those look? It doesn't look quite exactly like these distributions, but we can fix that. We can fix anything. So you can go here. If you're on a Mac, it'll be at the very top of your menu bar. If you're on a PC, it'll be right here. And you can click this little hand tool right here. We need to click off of it later, but we're going to grab the hand tool and we're going to do that. If you notice right here, we get a distribution that actually looks like theirs now. We can do a comparison. Nope. 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 Close. And is it the one behind my head? Of course it is, right? Of course it is. So here, can I get it right? Yeah, it's that one. I wish I could. It's so barely just not on the screen. Such a bummer. Oh, look at that. Look at that. We can fix it. There we go. And that looks exactly like it. So we have confirmed that this is the distribution. You might say, well, why did it look so different? Bin widths can change the way a distribution looks. So bin widths can drastically change. Bin widths are the amount of data that is collected inside of here. So it looks like there's one observation, three observations, 1, and 3. And so the bin widths, which we also want to put a count axis on here, shows us, and there's their count axis on the left. You can see how many observations are inside of each bin. And there's 3 observations between the range of 100 to 120, starting at 100, going up to 120. So this one is the answer right here. We have confirmed that. Create a normal probability plot. So the normal probability plot, if you know the rules of it, it narrows down the options. The normal probability plot will go up and to the right. So we really only have this option here and this option here. And I think jump can sometimes display it a little bit differently. I don't always love the way jump displays this. Let's go here to, my brain broke, and let's go to normal quantile plot. So the normal quantile plot is going to show us, yeah, let's do the 100 cookie question afterwards. You got it, Maya right there. Mia, right? Let's go here, and there's the way jump is displaying it. There we go. We're going to do that. We should be able to tell which one it is from this, right? I think it's this one right here. Jump's doing it a little bit differently. I think they switched the axes a little bit. But if you look right here, this is the normal plot right here, the normal scores, and they switch it over here. They have it on this axis, which it's just one of it's a little flipped for this question. They flip the axes. So probably if we rotate this around, we did like a flip of it. Yeah, it would be. Yeah. And so I believe it's this one, but let's talk about why it's not this one behind my head right here. These are the calories per serving. Look at this dot right here. This would be the maximum, and the maximum would be right below what value? So everyone, if you're watching right now, in this, these are the Y values right here. The maximum in this data set would need to be right below what if this is this data set? Which actually I think it is. And then there's a gap going to like 120. So that might be the maximum. Let's look. There's the data right there. Oh, there it is right there. I was like, that's not close enough. So this is going to be that dot right here. That dot is this value. That dot is this value. So then how do I know it is not this one? There's a big gap going from 178 to 120. And here's 178. Here's 166. Here's 161. There's not this big, and there's 148. There's 139. Look. 178, 160 something, 161, and then these values right here. But this one shows a big gap right here in the values, which there's not a big gap going from 178 right here, which is that dot, to these. So that other than looking at jump output, even though jump does it slightly differently, and seeing that this looks similar enough to this one, it's got a little flip of the axes, but there's no big gap. And you see that right here that there's no big gap going from the values. So this is the correct one. Pretty tricky on that one. Maybe harder to do. What are the assumptions? Randomization. Did we randomly select these? Yeah, we can do the rat race one after this. You got it, Adriana. Definitely. We'll do the 100 cookie, then the rat race. You got it. So are the assumptions and conditions for this met? Normal probability plot looks pretty good. So let's say randomization is met. Normal probability plot is, I think we want to go this one. Okay, the randomization condition is met. Did it say we took random? Okay, good. Random's met. Normal probability plot is relatively straight. That's what you want for a normal probability plot. 320 will tell you all about that. And the histogram is roughly unimodal and symmetric. Yeah, binwidths. So the nearly normal condition is met. Great job. 95% confidence interval. This is the great thing about using jump. Guess what? We've already answered that. Because we're using jump right here, jump actually creates for you a 95% confidence interval right here. So the 95% confidence interval is from 115 to 115.08 to 152.74, and we got it. If it asks for a different level of confidence, you can go right here to confidence, and you can enter in whatever confidence you want, like other, and you could enter in 98% confidence. Don't change anything right here, and it'll give you those other confidence intervals, but we're using the 95% confidence. So jump already does all that work for you. So that's the great thing about jump output. I am 95% confident. The true mean calories in a yogurt for these brands is contained in the interval 115.08 to 152.74. So that's 115.08 and 152.74. There we go. A diet guide claims that 130, yeah, that's totally believable. Anything inside of the interval is 100% believable. So the confidence interval contains it. Yeah, so the claim is supported. That seems accurate. Please tell me. I'm getting so afraid today. We missed one at the start because I didn't read it carefully enough, and now I'm just like, I'm gonna get them all wrong. I'm just like, no way. Let's do a cut in the video right here. Okay, 100 cookie question. 100 cookie question. Let's do this. We are just destroying these questions. I like this. Maybe we'll do these all today. So we did the parking garage. Hair's going crazy. 100 cookie question. 100 chip question. Here we go. Let's do it. Back to the main screen. Okay. So here we are with the 1,000 chip trial question. I got it. Thank you, Kinga. Let's do some 50 points. Kinga throwing out some support right there. Yes, we got this. Let's do this. Claiming that 18-ounce bag of its cookies contain at least 1,000 chips. Students purchase random bags. Randomization condition. Gotta do it. Random condition. Random chips. Here's the data. Guess what we're going to do? We're going to bring this into Jump. We're going to copy to clipboard. Here we go. Tab delimited. Hit Control C or Command C. So Control C or Command C. Once again, why that key is broken. And then we're going to go into Jump. And we're going to go to File, New, Data Table. Pause right there so people can see. File, New, Data Table. Pause the video if you need at this point to get Jump going. And then you're going to go to Edit, and we're just going to do regular paste. Reason we're doing regular paste is because there's no column name. You'll see a column name in, maybe we'll see one eventually with these questions, but it'll be at the very top. It'll be a column name. You don't want to paste with column names right now, because if you paste with column names, you'll see this, and it used the first value as a column name. You don't want to do that. Just regular old paste. So now that we have this into Jump, let's go ahead and start the analysis by going here to Analyze Distribution. This will analyze univariate quantitative data. Quanti-univariate, I don't even know. Let's go ahead and double click this, and we are analyzing this quantitative data on a univariate sense. Clicking OK right here, we'll get the histogram, and we're going to now just add in a few extra features, which we should practice for our project. So like our project, we're going to go here to Table Stack, or just the very top, and go to Stack, and that'll put it into horizontal layout. Next, we go here to the second red arrow. We go to histogram options and go to count axis. This is not required for this question, nor is it required to add a color to the histogram, but why not? So there we go. We got a nice looking histogram, and let's increase it. But that is our histogram right there. And as classic, let's see what's going on with it. Sounds so fun today. Okay. So in this video in the future is like, what in the world's going on? Okay. Check data for independence. The data is from a random sample, so one can assume that they are independent. Yep. So that's why we only really check random. Independent is wanted too, but if they're random, they're independent, so we should be good on that. That's what we say when we say random, is we're saying they're independent. Now, if you look at this, our histogram did not look like this. Does anyone remember what controls how histograms look? Like, our histogram does not look like any of these right now. Like, you're like, Brian, what have you done? Something's wrong. You already made one mistake today. So our histogram does not look like any of these behind my head. And the reason being is bin widths. Bin widths control how histograms look. These histograms start at 900 and go to 1600 and look to go up by units of 100. So let's change this. So to do that, I double click on this right here. And we're going to start here at 900. We're going to go, no, I don't want a 1 right there. And we're going to go to 1600. And then we will go up in units of 100. And let's click OK. And there we go. Looking pretty good. Looking pretty much like the other ones. And if we do this right here, we see it. And this goes from 900 to 1600. And yeah, starting at about, there we go. That is the histogram right there. So we have it. This one is the same shape behind it right here. And I do want to point this out. Like your project, sometimes you look at something and you're like, this looks normal. But previously, if we change it with this hand tool, where's the hand tool? There it is. If we change it, you might say that doesn't look normal at all, or that looks uniform. So it's pretty weird how you can get something that looks normal or not normal by bin widths. Bin widths is just how much data goes into the bin. And that's why we don't usually, especially in 320, we don't look at the histogram. We look at the normal quantile plot, and that's about as normal can get. Normal quantile plot is one way to analyze normality. The other way is to fit the normal curve. This is hints for your test. If we do the continuous fit of the normal right here, we can actually test to see if it is normal. And yeah, it's super normal. The test comes back, not that you can have the test say it's super normal, but the test comes back confirming we have no reason to say that it's not normal. We don't have any evidence against this. And look at that. Just watch out, change your bin width, and all of a sudden now it looks pretty not normal, but everything is confirming this is normal. I know you can change the bin width to make it look not normal, but everything looks good. Okay. So it is normal looking. Evaluate the histogram. The histogram is unimodal symmetric with no outliers. That sounds good right there. Create a 95% confidence interval. 95% confidence interval. We have so much on the screen. Oh my gosh, what have we done? I'm going to redo this really quickly right here because there's too much. Look at this. Here we go. Speed run redo. There we go. Too much on the screen. Here, we just had it. Why'd you do that? Here it is right here, right next to my head, back here. This is the 95% confidence interval. 1156.22. There's the lower bound right here. 1156.22. And here's the upper bound, 1324.58. And what does this evidence say about the company's claim? Because the confidence interval is entirely above, they claim 1,000 chips, right? Because the confidence interval is entirely above them, which it is. This is above 1,000. They're saying the claim is 1,000, so that's their claim. Because the confidence interval is entirely above 1,000, the mean number of chips per bag is likely more than 1,000. This does not mean every bag will contain at least 1,000. That sounds accurate because they're saying the mean number of chips is expected to be. It's the true mean. So we have evidence that the true mean. Whoa, did we just totally make a mistake on that interval? What happened right here? What happened? Did I misselect things? I think something happened with our interval right here. Something happened with this interval. Where did Brian? Wait. What is going on? Wait. The mean number of chips is likely more than this. However, the normal predicts that a small... Yeah, wait. Oh, this means that every... good. Okay. What is going on? Okay, that's correct. I think I got the interval wrong, which is really weird. Did I change the data, everybody? Yeah, it's... Wait. Okay, that's correct. Okay, the interval's wrong. 95% confidence interval. Let me rerun the data right here. Maybe I changed the data or I analyzed the wrong data right there. No, that looks like the right data. That's our second question wrong today, which is not good. Eleven 56 point. Leslie. Gosh, and please, this is a good point right here. Everyone's seeing it. Yeah, I know, right? It's is there a way to find comp strolls? We were doing some of those earlier, Kingo. We were doing some of them without jump, and everyone's pointing it out right here. There it is right there. Please tell me if you got it wrong for that reason. And the last question I just did not read fully. It's not that every bag will contain it. The normal model predicts that some bags might not, because the normal model, according to this, says that individual bags could contain chips that are outside this range. And we could actually see that if we look at the distribution of individual chips. So the distribution of individual chips has a mean of 1240 with a standard deviation of 117. So if we go back here to the normal model and we go to the mean of 1240 with the standard deviation of 117, individual bags could have less than 1,000 chips. That's not a z-score anymore, but we could see about 2% of individual bags. So just once again, I need to read the questions fully with that much text. Just the last part. I've done that question 100 times. Gosh. And I didn't round. Be very careful. And I do want to say this. Has anyone here ever emailed me and I've given you points back for your rounding? I would 100% give anyone points back right there who got that wrong with rounding. So please, 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 if you get it wrong because of rounding, email me. I'm just a little confused on how to find the comp roll on this one without the standard deviation given. With this one right here, yep, Kaylin confirms. If you get something like that wrong with rounding, please just email me. I will give it right back to you. I'll be like, yes, yep. Or they didn't give us the standard deviation right here. How did we in this one, we would not find by hand. This one's not a solve by hand problem. This is a practice reading jump output problem. You could solve this one by hand if you use the standard deviation or standard error right there. So in this one, you put it into jump and solve it. Does that make sense, Kinga? This one right here, we copy the data into jump and we solve that way. So this one here, we copy the data into jump and we solve that way. No more questions wrong today. We're not allowed to get any more wrong. Brian's going to watch all the decimals. He's going to double check everything. I always check decimals. I always check them because they'll ask like 10 decimals, 2 decimals, 3 decimals, 1 decimal. They'll change it every question. Does it make sense, Kinga, right here? And I think we did the 100. Can we do the rat race? Could you show one more time how to copy and jump? Yeah, of course, definitely. Go right here, copy to clipboard, and you want to hit Control or Command C. And this does not have column names. No, Kinga, that's why we're doing office hours. That's why we're here. And then you go into Jump, and you go to File, New Data Table. File, New Data Table. With File, New Data Table, you remember, did I have column names or not have column names? I did not have column names, so I'm just going to go to Edit Paste. So with Edit Paste right here, we get to this new column. And so this is a new column right here of the data. Just make sure to remember if it had column names or did not have column names. Does that make sense, Kinga? You're welcome. No, that's why we're doing office hours. It's, I throw some mistakes on here on purpose just to make sure everyone's watching. Like, oh, you didn't catch. Everyone, you're supposed to say, oh, Brian, what are you doing? You're not putting in the decimals. What are you doing? This one is a solve by hand problem. This one, if we want to do this one here in a moment, this is a solve by hand problem. We won't use jump for that one. I don't know if we can do that one. Let's see right here. Flights, the rat problem, the rat research. Where is it? Where is the rat research? Here we go. This one's tricky. I think this is the only one where you have to remove the outlier. We're doing all the tricky ones today. So we have here another jump data table. Here's the jump data table, and this looks like it has a column name. So since this has a column name, when we go to, oh wait, we got to do a cut in the video. We can't get anything wrong today. Okay, no more things wrong. Let's do this. Let's do the next problem right here. And here we go, just getting hair ready. Okay, this is the rat race problem. Let's go ahead and take a look at it. We've got some jump data, and it has a column name. That's an important thing to know when copying data into jump. So we're going to go to copy to clipboard. It does have a column name, so Control C or Command C. And here's the big thing to remember. When you go into jump right now, and you go to File, New Data Table, you can always access this at jump. It might be in the top left corner for you right now, but go to File, New Data Table in jump, or you can hit Control or Command N. And now you're going to go to Edit, Paste with column names. I'm pausing right here because this is so important. If you do not paste with column names on this one, it'll cause an error. It won't work properly. So let's paste with column names, and you'll notice the column name is there. If you have this, you've done it incorrectly. So this is the incorrect way. Do not try to fix it. Start over, go to File, New Data Table. There is a way to fix it if you make this mistake, but it's more work than just pasting with column names. So paste with column names, you'll see that this is blue. If this is not blue, it was done improperly. Start over and paste with column names by opening up a new data table and then paste with column names. And that is how to properly do this right here. So we have the data pasted into jump right here. Let's go ahead and go to Analyze and then go to Distribution. We're going to double click this right here. And we have right here the quantitative variable to analyze. We're going to go and hit the top right arrow and go to Stack. And now we have our histogram. So it's going to ask us which one is the proper histogram. None of these look exactly like ours, but let's take and go from 20 to 100 by units of 5. So let's bring back up our data, and we're going to double click down here. We're going to enter in 20 to 100 by units of 5, and there we go. That looks a lot like this one. You notice the outlier up here, so we've got this one. There is our data. Like, I'm double checking. We're never going to make errors again. Yeah, with that outlier, it's definitely it. Choose the proper normal probability plot. So normal probability plots are a way to analyze if distributions are normal. They always go up and to the right. So this one is wrong. This one looks ridiculous. They can't follow that pattern. It has to be between these two right here. Now this one is perfectly normal. That is a perfect normal. Ours is not perfectly normal. This one right here is going to be the answer just by process of elimination with what I know about normal probability plots, but let's go ahead and make it in jump. Jump does them pretty similar, but a tiny bit different. So you'll notice it doesn't perfectly follow the line. Let me try to get it all on the same page here. So there we go. Here is the one in jump that it does not look like, but you notice this right here is the perfect line right here. Jump changes the axes just a little, so it is this one. It's just been flipped. I bet if I mirror image it, you know what I could do? Because I want to show you that this is the one, but I just hate that jump slightly changes it. I wish I could flip using this right here. The axes and jump are a little different than the my Pearson, which is a little confusing. I do agree. Let's change this and show that it is that. Let's go to, where's picture format? Rotate. This might do it. Oh, it has to go up and to the right. And let me try one more thing right here. Rotate. Oh, is that the same exact picture I just took? It is. I'm trying to like mirror image it. Oh, I think we've done it. Is that the way the jump one looks? I mean, the my Pearson output one looks? No, it's going to be so hard to get their picture to look exactly. Oh, wait. We've done it. Yes, if you see right here, we've done it. We've created the same. No, it's not. Darn it. It is this one right here. And another way to tell is by the values. I hate that jump does it slightly different. It's just that different statistical software is doing it a different way. And this is the correct answer right here. This is a perfect normal. Ours does not follow perfect normal. You can also see this high value right here in the 90s, and there's a gap in the data. There's the gap right there. That's that gap right there. And here's this gap right here, and that's that gap right there. And it does not follow the perfect normal. This would follow a perfect normal behind my head right there. Little tricky, but this is the answer. The more it follows the straight line like this, the more normal it is. The less it does, the less normal it is, but that's not too abnormal. And you can see that in the jump output right here, where this follows the line decently, but has a deviation up here with this top outlier. So you're seeing the same thing, and this is what you should understand. This is the perfect normal, and our distribution does not follow this. Are the conditions for the inference satisfied? Uh-oh, now we're into the hard questions, the ones that we can't just automatically know. Randomization. The plot is relatively straight with one outlier, so that eliminates this one. This question has been eliminated because there is one outlier up here. Without the outlier, the conditions seem to be satisfied. The histogram is roughly unimodal and symmetric with no outliers. That's without it. Where's the differences? Without the outlier, the conditions seem to be met. Good deal. So let's see. Everything's the same right here. The histogram is roughly okay, good. It's unimodal, and we just kind of did process of elimination on these because the normal probability plot is roughly straight, which is what we were looking for. Oh, see, these say not straight. Okay, that eliminates down to these two instantaneously. And then the last bit right here says that it's bimodal and skewed to the right. It's mostly unimodal. Let me double check. Oh, no problems. Yeah, I'm glad you got it. We can do that next year if you want, even if, yeah. Eliminate the outlier. We'll do that here in a moment. So the histogram is roughly unimodal and symmetric with no outliers. See, it says no outliers. I think it's talking about without the outliers, the condition seems to be met. Yeah, without the outlier, it'd probably be more met. So to eliminate the outlier, we need to go here and highlight the outlier. Notice how this has been selected. With the outlier selected, we are going to go to rows and hide and exclude. So we're going to go to rows, hide and exclude, and it'll actually, let's go here, go to redo, and go to redo analysis now. So we hit it, it's gone, and we have to redo the analysis. So now with the analysis redone, you can see it actually follows the normal pretty well. And if we change the bins on this, it might look super duper normal. Let's see here. No, it doesn't really have much of a right skew because the mean is not higher than the median. So I am happy to say mostly symmetric, follows the normal. And we want to look at this output right here. And so it says eliminate the outlier and find the conf interval again. Okay, good. It never asked us for the conf. Oh, we do. Apparently we need to get the conf interval first. So I need to go back here. And we need a 90%. Of course it wants 90%. Let me make sure everyone knows exactly what we're doing. We need to get that 90% conf interval. Let's copy the data. Copy, copy, copy. And let's go to a new data sheet. So there's our times right there. Make sure to paste with column names. Edit, paste with column names. And so a very important thing we're going to do right here is we are going to make the distribution of times. And once we make this, here's a trick. We are going to go here and go to redo, and put on automatic recalc. So now when we go to confidence interval and go to 90% right there, 90% confidence interval, we get a 90% confidence interval for the mean, and it's 45 point, let's see how many decimals. 45.64, what was it? 45.66. Double check. 45.66, 54.27. 54.27. And now watch this. When you go down here, and this only works if you've gone here and went to redo automatic recalc. It only works if you've done this. So now, where's that outlier? Something's weird about this. That outlier's not here. Oh, I've probably got, oh wait, this is the actual interval. Darn it. I'm making so many little errors today, everybody. People in the future are like, wait, what? Because the outlier's not here, which means I've just done this problem. So I was working in the, I'll explain what happened right here. So check this out. Rows, clear row states. Whoop, there's that point again. So the automatically crowd, yep, we can do flights next. I've been jumping around so much today. So this one right here, with the automatic recalc on, it automatically recalculates the interval 46.63. 46.63. And right here, 47.10 it rounds, 57.10. And I just want to point out, let's start this from the beginning. Copy to clipboard. And when you copy this, you have the outlier to begin with. So we're just doing it really quickly right here. And this is with the outlier. So when I make this confidence interval this time, this will be with the outlier. So confidence interval, 90%, and that confirms this answer right here, 46.63. 46.63. And the other one is 57.10. 57.10. Now, to make the interval without the outlier, we're going to go up here and go to redo automatic recalc. We're going to remove this point, and with automatic recalc on, it'll automatically recalc. When we go to rows, hide and exclude. So now it'll change this output right here. So 45.65. Let's double check, make sure we got those right. 45.66 rounds 2 and 54.27 rounds 2. So does the maze meet the requirement that it takes at least 1 minute on average? The maze does not meet the requirement. Both confidence intervals are entirely below, and I think they are. Both confidence intervals are entirely below. The maze does not meet the 1 minute requirement. Let's hope we did all those rounding. 2 decimals. Oh gosh, I needed that. That's awesome, Kinga. Great job. You're making less errors than me. That's awesome, Kinga. I'm trying to think, do we have another question lined up before the flight question? We can do the flight question next here. Great job, Kinga. Adriana, great job too. Everyone, make less errors than me. We didn't make any errors on this question, but I kept bouncing around. I try to be as concise and awesome. See you in class, Kinga. I'm getting the flight question going right here. Let's go check out the flight question. Let's ace it. You ready? Let's do it. Let's ace that flight question. Okay, with this one, it's all output. So this one right here is excellent. We've got the randomization condition. So we have here the nearly normal condition. All conditions and assumptions are met. I'd say so, because we can select what is not met or what is met, and we just need to select all conditions are met. All the assumptions and conditions for inferences about the mean are met. So we're doing a confidence interval for the mean right here. We have the sample size, we have the Y bar, and we have the S. So what else do we need from this? Who can name what else we need to make a confidence interval for the mean? So to make a confidence interval for the mean, what else do we need? We need one more thing right here. So I'm going to start writing the equation, see if you can solve what else we need. So Madison, what else do we need right here for this? We need one more thing especially. What else do we need? You're right. Great job, Samantha. Excellent work. So we're going to get the degrees of freedom right here is equal to 71. And then we're going to go to the applet. let's go ahead to the applet right here. And with the applet, we are going to go in and put in degrees of freedom 71. So with degrees of freedom, let's go to T applet. Oh, watch out. That was the Z applet. Nice job, Madison. Yep. Degrees of freedom 71. And because it's n-1, degrees of freedom 71. And this question says it wants a what percent confidence? 99. That's going to be a big t-score. So 99% confidence. And we go to the between one right there, and we get a t-score of 2.647. 2.647. So that is our t-score right there. 2.647. Here we go. Let's go and plug in the numbers. 2.647. And then we plug in the S. Oh my gosh. That is quite well estimated. We plug in the square root of the sample size. We do the plus or minus here. We do the mean. They really wanted all the decimals carried out in this problem. So let's go ahead and take and plug in 72 square root, and we take 2.50533 divide by times by 2.647, and that is the margin of error. So we're just going to plus or minus, so 24.4722 plus or minus 0. Is that a 5? Yay, it was. Awesome. And so let's go back to the problem now. And there we go. So now we're going to take this and we're just going to add and subtract. I've got that in my copy paste. 24.4722 plus this 25.25, 2 decimals. And minus this 23.69. And let's take a look. Interpret this interval in context. We are 99% confident the interval contains the true mean. That sounds correct. So I am blank percent confident that the true blank is contained in the interval blank to blank. That sounds like our format right there. We've done excellent. Is that it? Have we done it? Awesome work. There we go. Follow the harder part of this is going to be this one right here. The conditions are random 10% and nearly normal. And that meets the nearly normal. As long as these are random flights selected less than 10% of all flights, which makes sense. It'd be less than 10% of all flights. But excellent work. You're welcome, Madison. Excellent work. Let's see here. We got a few more. We've been doing great. We've been knocking out a lot of these questions. This one right here is pretty easy. Let me put a cut. Makes it so much easier. If you have another one you want us to do, feel free to ask. But everyone's doing some great work. Working through these problems, identifying the notation is key. Let's hop back in and do this one right here. Okay. Explain carefully what this output means. I am blank percent confident that the true blank is contained in the interval blank to blank. So we say our confidence level first. So this sounds like we are blank percent confident that the interval from blank to blank contains there's the true, which is important. And we're estimating the true mean because this is mu right here, which is the true mean pulse rate of individuals. So that sounds right. Now the margin of error is always what the length of the interval. So whenever you hear margin of error, you should think this is what the length of the interval. The margin of error is always what the length of the interval. The margin of error, let's go ahead and take the length of the interval. The length of the interval is just the large number minus the small number. So I'm just getting how far are these numbers apart. So the margin of error, I'm just going to get how far these numbers are apart. This is how far these numbers are apart right here. That's the distance. And then the margin of error is just half that distance. So margin of error is half the length. Like if you have an interval that goes from 40 to 50, the margin of error is plus or minus 5. So the margin of error is half the length of the interval. So we're just going to put this right here, and that rounds all the way down to that. The margin of error is half the length of the interval. So it's just half the length of the interval. If the researcher had created a 90% confidence interval, what would the margin of error be? Would it be larger or smaller? So this is going from a 95 to a 90, and questions like this are in 320. So I was looking at the 320 exams and seeing a few students missed it. It's all right. But this question right here going from 95 to 90, think like 68, 95, 99.7. So if you go from 95 to 90, the margin of error would be smaller. So the margin of error would be smaller if they went from 95 to 90. Going from 95 to 90 is 95 to 90. So you're getting smaller interval. Just think about how much of the curve you're covering when you do this. if you go from 95 to 90, you're going to cover less of the curve. So, you know, it works like 68, 95, 99.7, which this is the T curve right here. So the number, oh, that's 99.9. There we go. This is the T curve right here. So it's not the exact same as Z-scores, but it still works if you went from a 95 to a 90% confidence interval. 95 and 90% smaller interval. So great question right here. Nice and easy one. Let's hop back to another question. Try and do as many of these as we can. You're welcome, Caitlin. Yeah, it's good practice. And thank you for being here. It's just good to practice these things and memorize these things. Like the more confident you are, the wider the interval is. And that relates to the T or the Z score. So all that good stuff right here. We've done one just like this. We've done this. Oh, this is another flights one. I might do my favorite problem really quick, just for fun. Yeah, let's do my favorite problem. Here we go. Let's do my favorite problem, nice and fun. This problem right here is using the T's or the Z scores from the applets. We'll put this in the chat right here. So this is, you know what we could do? Let's give MuBot a command right here. MuBot. So MuBot is going to get a command right here. Oh, he already has that. Go here. Oh, no, that's the 2-sample T. So command plus new command. Command, exclamation mark T. And he'll say, here is the T applet. And then he'll give you the T applet. So let's see if MuBot can now talk to us. Are bar charts and histogram the same thing? I'm working on the project. I'm a little confused. Bar charts are for categorical data. Histograms are for quantitative data. Which one are you working on? Feel free to ask. Bar charts are for quantitative and histograms are for, oh my gosh. Bar charts are for categorical and histograms are for quantitative. So here, where's our graphics screen right here? Oh man, MuBot, you're so awesome. You know everything now. Here's our graphics screen right here. And you can see which graphics are for which. There's our graphics screen. So if you want to take a screenshot of this, histograms are quantitative and bar charts and pie charts are categorical. Because you can make a bar chart of your favorite pies and a pie chart of your favorite bars. I should seriously put that up as one of my graphics so I can do the all graphics at any time. But MuBot now knows the T applet, so we can ask MuBot about the T applet at any point. Find a critical value of a 95% confidence interval. So 95 is 1.96, but this is going to have more. It's going to be wider. The T is always wider than the Z. The T are always bigger intervals. Section 2, Part A with weather. Weather would be a bar chart. Yep. And make sure to include the counts and the count axis, all that good stuff. If you have any questions, Kyle, we can do that next here if you're wondering. But great job, Kyle, working ahead on the project. Awesome. Keep asking questions. That would be, weather would be a bar chart because weather is like whether it rained or not. Like that's what weather is. And so that'd be a bar chart. Yep, bar charts are categorical. So it'll actually, I think it says histogram options when you bring it up in Jump, but it's actually a bar chart. We should talk to Jump about that. I just met with Jump. 90% confidence. Can we get these both correct? Can we do it without the applet? The answer is yes, we can. So I'm confused because the video, bar chart, and frequency table in Jump 1 minute tutorials shows you working on a histogram. Let me go look at that video after this. Yeah, good question. It might say histogram options, but that's one thing I've always disliked about Jump because it says that when you go and work on it. So let's take a look at that. Great questions. 28. Here's how to put it into the applets right here. And so we were close enough. It barely gave us that one. And so there's the T value. And then this one is 72 degrees of freedom. 72 degrees of freedom with 90% confidence. And yep, we got that one almost exactly down to the decimal. So the applet right here, which is in the chat, will let you solve with the degrees of freedom. And make sure to select this right here, very important. And let's go take a look at Kyle's question. Let me go look at that 1 minute tutorial that I made. So project playlist. Here we go. So I've got the 1 minute tutorials up. Let's go take a look. See if I have anything I disagree with here. But this website says I need to go legacy. Oh, I wonder if Charlie Quicks have been updated. I'm bringing up, wait, where'd it go? Okay, bar chart with Jump. Yeah, you know, we might need to remove Charlie's stuff because I don't know if he's keeping it as updated or I'll have to look. Okay, let's take a look. Good questions, Kyle. Let's go take a look at everything right here and take a look at the project. So here, let's hop in. Okay, so we're on Charlie's site right here. I'm trying to think which version of Jump Charlie has right here, because Jump just came out, Jump 16, and so we're using Jump 15 probably. The version of Jump's going to change everything drastically. So they have Legacy right here. Do we currently have Legacy in Jump 15? The answer is going to be, let's go over here to a data set where we have a big enough data set to work with some stuff. And under Graph and Legacy, and yes, we can still do a bar chart via this right here. So if you add this in right here, you can get a bar chart, and you can go to, I haven't done this one in a while. Here we go. We should be able to go to, where is it? I think you right click. Oh my gosh, where is it? It should have the option to add the counts above. See, the thing is, it's doing it via the graph builder now. I know, right? They've done this so many times. Like they've changed the way it's done. Let me go. Yeah, let me look at my video and see which my video has, because we should be able to add the counts to this. See, it looks like it's just doing it via graph builder now. Hover label. That's good. Really? We don't want to do that. It's going to do a histogram. That's interesting. Let me go right here. This is the way I would suggest nowadays. Will make life a lot easier. If you just go right here, and I think we can add the options right here. It says histogram options is still a bar chart. You can go to count access, which I always support us having. And then we should be able to add the label. So let's go here to the option right here, go to histogram options, and go to show counts. This is going to be the best and easiest way to go right here, to just get everything you need with the counts above the bars. Does this make sense right here, Kyle? And then let's take a look at the other stuff. Let me see what Charlie Quick has, because I might need to tell Charlie that, because what's crazy is they update Jump like every other semester. So we can get like out of date on something so quickly. So he's putting it there. Then there we go. Label options. You see, it's not the same. That's such a bummer. I think Jump 15, I'll have to tell Charlie that this one's out of date. The label options might not be there anymore. And that's what I was looking for under the red arrow. If we go to graph, legacy, chart, so he just put in a categorical variable, and then he goes here, and I don't see label options anymore. So unless I'm going crazy, and that's what I was looking for, and they might have hidden it somewhere, but there's no label option, because he is using label option right here to go. If you notice under it's you see it's using graph builder. So Jump 14, which I don't think I have on here anymore. Maybe I do. Let me see if I have Jump 14. So, and then my video right here, bar charts and frequency tables. The green icon represents. Okay, we know what the variables are, Brian. We get it. I am doing it via the. I think I'm doing Now the graphic first appears in vertical layout. I like to go to the top right arrow and go to stack, which will turn it to horizontal layout. Yeah, I hate to say it, and I'll have to tell Charlie. Do I add the? Might not add the numbers above it. I don't see why we need the numbers above the bars. I don't think it's that important, and maybe I'll talk to Terry and I'll say like because I don't do the numbers above the bar in the video. I don't think it's super important, because you can see the counts right here to do the numbers above the bars. And there's got to be a way via Graph Builder to do it. So this is with Graph Builder right here. There's got to be a way. Label. There it is. Here it is. We just found it. Label by value. Boom. Got it. Okay, there we go. That's exactly what Charlie does with his. But if you notice, this is hidden right now. Very, very hidden. So I think, and let me look at the project to see what it says you need. We had the project open earlier. Let's go take a look at what the project says you need. I've got so many windows open. The project for this one says Your bar chart must be displayed in horizontal layout. Include the values, either count or percent above the bars. Take a screenshot. Bar charts and frequencies. Okay, so yeah, I'm gonna say to Terry, I don't know about this numbers above the bars. My video doesn't include it. The numbers are included anyways, and so I would not. Here's the thing, though, I would not do it via Charlie's one. Sorry, Charlie. Charlie's thing is out of date now because they've changed how it works now. My video doesn't put the numbers above the bars, but I'm gonna say to Terry, I don't think that's super important. Like if they use Graph Builder, I think they should have the numbers above the bars. But so like, here's going to be my suggestion when I talk to Terry. If you use Graph Builder, then this would be acceptable right here because it has the frequencies. If you use this right here, I don't think you need the numbers above the bars. So I don't think, because I just, you've got this right here. And this is what it's talking about when it says include the, which one do you want to see for? I can show them both. So let's go right here. If you're making this one right here to add the numbers above the bars, go here to Analyze Distribution, select your categorical variable, and it'll say histogram. Just ignore that it says histogram on all this. It is a bar chart. It's just via the histogram platform. You're going to go to Stack. That makes it in horizontal layout. So right here, we are talking about this one right here. So create a bar chart of weather. So it's just categorical variable like this. Your bar chart must be displayed in a horizontal layout. This is horizontal layout right here. Include the values, either in counts or percentages. So to include the values, you'll go right here. You'd go to histogram options. You'd go to either show counts or percentages. Either one is fine. Let's do the percentages. There's the percentages right there. Makes it a little bit bigger. So there's the percentages. Take a screenshot of the output, bar chart, and frequencies. So here's the frequencies right here, but it should also be acceptable to kind of do it the same way Charlie's doing it. If you were to go to graph, legacy, and chart, this is going to be, mention this, but it's okay to include the dots. You definitely want to include the dots. You should include the dots. I would include the dots because dots are going to include outliers. As long as the outliers are included. I can take a look at that here, Leslie, next, if you want. So this is the other way to make the bar chart, is to go right here, select your variable, and here's the bar chart the other way via the platform, but now you must add in, and this would count as the frequencies, and Terry should know about this variation because we need to go to label, so bar, label, and you could do either one of these. So you have to go to bar, label, and then label by value, and then you have the values above this now. So this would work right here. I do think this is acceptable. It contains the same information. It doesn't have the percentages like this one does, but these are the frequencies with the percentages. So both of these should be acceptable. Both these are valid displays of data. To go to here, we're going to put a cut in the video. Let's talk about those. Which one is it that we're doing these side-by-side box plots on? Let me take a look. Side-by-side. Here we go. Create side-by-side box plot. Let's take a look at that. Let's go back to the main screen. Yeah, I would do the first one. I'm going to tell Terry, though, that we should be, like, either one is fine. So Terry should know. And I think with the first one especially, you shouldn't need the numbers. So I don't think it's super important to have because in the first one, the numbers would be, does that make sense, Kyle? I'll be telling Terry, like, if they have the numbers in there, I don't think they have to be above the bars because they have the frequency table next to it. So, I think the graders should be nice. Like, here's two valid ways of doing it. So, yeah, sorry for any confusion on that one. But I think either way is valid way of doing it because it's like there doesn't have to be one exact way of doing it. As long as you have the numbers and everything, that's what we're looking for. Create a side-by-side box plot using this quantitative variable and this categorical variable. So we have right here, add the quantiles from the triangle. So they're doing it this way right here. Let's go and analyze this. So when we do this, we want to go to fit y by x, and we're going to add in a categorical variable and a quantitative variable. And we can see right here, we can get the box plots by doing the following. Quantiles right here. So there is side-by-side box plots. I think I have this one. Yeah, no, Kyle, this is great. Kyle, great job. Get the 100, get the 107. So here we are. We want to include in these dots right here because the dots are going to be the outliers. And I think this should making a side-by-side box plots.
Hey everybody, next we go.
And I think I add in the 5 number summary, yeah.
Present to the user.
So this is another way of doing it, which is fine to do right here. We need to make sure we add in that right there. Let's add that in.
We want to analyze right here.
Let's watch my video again.
A side-by-side box.
Side-by-side box plots.
A little more information. Add in the. Let's go here. And
there we go. So this is the other way of doing it right here. If you want to do it this way, this is fine. But we can also go here to graph and then graph builder. And then we put here a categorical variable down here. We put a quantitative variable up here. We go to a box plot. We've got the box plot. And then right here, we add in the 5 number summary. And now we've done it. And we click done. And either one of these should be valid right here because you have the quantiles. That's what we're mainly looking for. How many sentences do I need? Oh, for the, here, I'll talk about that in a second right here. But both of these are valid ways right here to make side-by-side box plots. This is more what the instructions go through. Yep. So if you have either one of these, Leslie, you should be good. You could have outliers. You might not. Like, just don't delete these. You don't want to delete these out of your output. They exist. If they exist, then they exist. But both of these are side-by-side box plots. And there's just multiple ways to do things in Jump. There's just like 10 ways to do the same output. This is what it mainly is talking about by adding the quantiles right here. So when it says add the quantiles, which is the same thing as going over here and clicking, we'd have to open up the graph builder screen again. But doing the 5 number summary, and make sure to click done. Please make sure to click done. But yeah, so either one of these, we'll put them both side by side right here. Side by side box plots. Inception. So both of these right here are valid ways to do your side-by-side box plots. Either way, make sure you get one of them done, and those are the side-by-side box plots. Here, we'll head over here. Let's put on a little music. Let's talk about Kyle's question. So for the write-up on whether I am just saying how many days it was... Yeah, I think so, right, Kyle? Task 3 on assignment 9. I am going to be teaching in just a moment here, X. We might have to do that next. We might have to talk about it at the end of class or something. Can we go over how to solve the equation we made? Yeah, we can do it real quick. You ready? Let's do that. Let's do that. We got time. We got time. Let's go. Oh, no. Let's do it real quick. You ready? So when we solve the equation right here, we get some sort of variable y. Not y like that. And with this equation y, we have here an intercept. And then we have here these variables. And if we are doing indicator variables, these can only take on values of what and what. X's for indicator variables can only take on values of what and what. So if we have indicator variables, these can only take on values of what and what. So if you've written the equation, which sounds like you have, indicator variables can only take on values of what and what. If you've written the equation, indicator variables can only take on values of what and what. Because either the indicator variable happens or does not happen. 0 and 1, yep. So go to these indicator variables and put in values of 0 and 1. And then solve through. Does that make sense? So then you'll solve through and you should get a value for whatever this y is for, I think you're also working with demand. Does that make sense, Master, or X? Right here. And you can double check, like email me and double check how many sentences do I write for each analysis, as long as it thoroughly answers it. If you want to check, Kyle, send me one of your analyses. You just, yeah, as long as it thoroughly answers it, like as long as you're like, some of them are pretty short. Like, was it the rain one? Let's see right here. Include a short write-up of the different levels of variable. You'd be like, yeah. If I were to include a short write-up for this right here, I'd be like, there are 23 females in this data set. There are 17 males. There's slightly, it's almost 50-50, but there's slightly more females than males. Does that make sense? Like, very short write-up. Like, from this data set of 40 students, I observed that there are 23 females and 17 males. This is almost a 50-50 split, but we see there are slightly more females than males. I could also do the percentages. I could say something like, what would that be? 57.5% were female, because 57.5% were female and 42.5% were male. So there's not much to write on this one. Like, 3 sentences is going to be like overkill, but hey, never hurts. Just write a little bit more. Just, you know, I think it helps to have the other output for this a little bit better here to have this, because you can actually see like, yeah, no, and great questions, Kyle. So you'd say something like, from my sample of 40 students, I observed that 23 students were female and 17 were male. This is 57.5% female to 42.5% male. Although this is close to a 50-50 split, it's a little bit, the sample is a little bit more female than male. That is, I mean, that is like as much as we could possibly say about that. Yeah. So awesome. Awesome work, everybody. With that, we'll be back. See everyone in class. See you soon. Bye for now, everyone. Bye.